You want your code to be easy to understand and safe to change. When anybody looks at it, you want the intent of your code to be clear, and you want to be able to have code that's flexible in many ways. So Python type-ins is amazing how it can help you achieve this. And we're going to do a deep dive on Python type-ins, type annotations today, and really look at what you can do with it. At the end of this video, you're going to see how 6 lines of code with a backend built in with Python type-ins, and also we're going to go into Pydantic as well and combine that as type annotations. How with only 6 lines of code, you can have a phenomenal API. Let me show you what that's going to look like. So this will be the API that we're going to cover. This is going to be a backend for a role-playing game. So this is part of Voyager Quests that we'll be building something like this. As you can see over there, you have a character with attributes. The character, what you're seeing over here is Swagger user interface. The API we'll build will be fast API, and it'll automatically generate this user interface for you. So let's just try this out. Once I execute it, you'll see over there, it creates an ID for me, and that data was sent to the back end. Let's break something. So I'm going to just send in the wrong data. 2 things I'm changing over here. And the moment I'm sending wrong data, it'll warn me and tell me that I cannot send a value. The value needs to be less than 100. Less than or equal to 100. So the value is invalid, 120. Also, the next warning there is the attribute I'm sending in X, Arcana, which was Arcana, is not valid. And then also, part of this is this API will generate OpenAPI spec for us. If you look at this, all the data is in here, and that spec can be exported. And the other thing it will also do, it will create a redoc. Redoc is similar to Swagger user interface, but you cannot execute, but it's really, really helpful for large and complex APIs. So let's jump in and look firstly. What we'll also do is we're also going to do a command line application, also with 6 lines of code. And this is an example of me accessing the same backend now, but through command line interface. You can see the code, but we're going to delve into this code. And once I execute this, it's going to give me the same error once I try to do 120 over there. So let's jump in and see how this is possible. Part of this, we're going to cover the following: foundational types and collections. We're going to do unions, optional and collection type, abstract, base classes. We look at literal and type dictionary types. And then we're going to move from the type dictionary and literal type annotations to Pydantic. And we'll combine type annotations with Pydantic. We're also going to look at behavioral and generic typing, some fascinating code that we'll look at over here. And finally, I'll step you through a modern way that you need to use types. There's a lot of, especially if you're using AI, it's going to generate a lot of old code for you. I want to show you what you need to change to make your code modern and even more Pythonic. I almost said Pydantic, but even more Pythonic. So let's get started with foundational types. This is going to be quick. So that's a function that's not typed. Typically, it doesn't have type annotations. And typically in the old school way, you would add doctype like this. Some people still swear by doctype. I'm more on clean code, which says you don't want to write comment if you don't need them. You want your documentation to be inside your code. And that is one of the major benefits of type annotations. Let's run this. When I run this in a wrong way, I'm getting an error, and nothing warned me about the error. That's the other big benefit about type annotations, is when you do it right, you're going to get early warnings of mistakes while you're busy working. That same function looks like this once it's annotated. So simple name string returns a string. And now as we work in the IDE, I'm getting argument of type list string cannot be assigned to parameter name of type string. That's the type of warning you'll get in your IDE. That's just the basic. I can still execute this function and it can still go into a backend and it can still break stuff. Types do not affect the runtime environment, although once you use frameworks, those frameworks use type to change the runtime environment. So keep that in mind, but you can still run Python code that will create bugs. And that's where Pydantic's going to come in. So let's run quickly through the different type of basic types. Count integer, that's a float. That's why you do a bool, a string, a byte, and then none. We'll see the none type again when we do optional. Let's move on to built-in collections. Collections are now built in, so you don't have to import them anymore. This is a great example. So list of integers, then a tuple with an int and a string, then a tuple with float with an unspecified number of values. This is how you do it. You use an ellipsis to indicate unspecified amount, and then we have the type there of float, which means this tuple can only take float. A set of strings, a frozen set of ints, a dictionary with a string key and an integer value. Now we're going to look at unions, optional, and collection type abstract base classes. So take a second and look at this function. What does it do? See how you would use it. Just maybe pause the video and take a few seconds and do that. So this is an example of, it was developed for sending in a sentence and it's going to count the characters in that sentence. However, when the developer developed this, they had another intent in mind as well. But I want you to firstly look at this. Do you think this is still going to work? Is this list still going to give you the correct value? Just think about it for a second. And sure enough, it executes, it gives you exactly the same number. How about this one? Will this one still work? So I'm sending in now a list of tuples, each tuple containing strings. And as you can see over there, this is not a valid use of this function. However, purely looking at the function itself, you don't have the ability to identify whether it's going to work or not. So let's take this function, and as you can see over there, once I execute it, it's giving me a wrong value. It's basically giving me 7. Well, this is one of the worst types of errors that you can get. When something executes, but it's giving you corrupted data back or wrong data back. It can be like a silent error. How do we protect ourselves against this? So we're going to use type annotation. As you see over there, I'm now saying words, and I'm annotating to say a string, and that's where union comes in. String union, a list of strings, which basically I'm saying that you can pass in a string or a list of strings, and this will return an integer. So simple. The benefits I'm getting firstly is if I'm a developer and I look at this, it's now, I don't have to wonder. I know that this function was tested for these values. You have here two correct uses, line 7 and line 12, and you have one incorrect use. Now the big difference now is that your IDE will warn you that this is an incorrect use, and that's an example of the error that you're going to get. Argument of type list cannot be assigned to parameter words of type string, list string. So it's telling you that the tuple we're trying to send in there is invalid. And it still executes, and I'm still getting 7, but at least we're getting the heads up. This is what your IDE will show you as you're busy typing the incorrect usage. You're going to get that same error. And the great thing with types is it becomes live documentation that your IDE can interpret and show you how to use a function. Have a look at this. So it's giving me the spec of the function over there, words, and it tells me that it takes a string or a list of strings. The other great advantage of types is it can allow a developer to expand a function safely. So when I look at this, I now see that the developer have has only catered for string and list of strings. But as a developer, I want to make my function as flexible as possible. Or at least I want to add some flexibility. If I've developed it and I'm seeing, this can also be used for a set of strings, as an example. Currently, it will block a set of strings. So this is an example of what you'll do from a typing point of view. And this is where abstract base classes come in. Have a look at that. We're importing from collections.abc. This is also the modern way to do it. You're importing iterable, and you're now adding a type, because any iterable would be able to work for this function. And that's an example of how much flexibility I've added. Line 9 to 14 gives us an idea of how we can be used. We can now pass in a list of strings, a tuple of strings, set of strings, generator yielding strings, iterator of strings. Any iterable can be passed in, but our previous incorrect usage will be blocked, and we'll still get that warning if we try to use it in this way, which now the warning will be a little bit different, but still blocks us in the IDE from doing this. So have a look at, I'm going to step through the different type annotations here that we've got. Unions, line 3 shows us an integer or a string. That would be an integer union string, which means or. Name union none. And this is now the new way of specifying optional. You don't have to import optional anymore. You'll basically union with none to say an optional value. Union list of strings, or a list containing either a string or an integer value. And then we have all of our abstract base classes. I'm not going to go into the detail of what every one of these mean. If you don't know, it would be nice just to quickly read up about them. Iterable, iterator, sequence, collection, container, and reversible. These are all the different ones that you have there. So we're going to look at literal and type dictionaries. Now this is where it's going to start getting fun. So we're going to take this piece of code, and this will be one of the functions in our backend to update attributes for our role-playing game. See if you can figure out how to use this. Imagine you're in a big team and all of you guys are working on this, and somebody tells you just use this function. You're looking at this without any docstring or without any type annotations. You're not going to have any clue. And then you can ask around. Everybody's going to tell you, oh, this is how you use it. Or you're going to be looking at other code and trying to figure it out, which is where it becomes dangerous. And that's where teams start slowing down, because that type of communication is difficult and people start making mistakes. And especially when corrupted, incorrect data starts entering the backend. Okay, so what would docstring look like? This would be a proper docstring, but now I would hate having to write docstring like this for every function. So why do we need it? We don't need it anymore. If type annotations can really help us to avoid the docstring that we need to write here, that's one great reason already to use it. So if I have the docstring in front of me, I can create a character to send into the function. Down there is an example of creating the character. See if you can spot the two mistakes I've made. So line 20 and 19, attribute without an S and might without a M. Once we have the corrupted data on the back end, the problem now becomes that valid code starts breaking. Here we have a totally valid function, and somebody executes it because the data is corrupted in the back end. You have a mess. And then things really get messy. So we're going to implement literal here as a first mechanism to protect us. Literal type annotation is a set of fixed values. And that down there is an example of how the IDE, Visual Studio Code in this case, is going to help you with literal. It literally gives you a list of values to pick from. So from literal, that's in the error, we're going to move to type dictionary. Typed dictionary is a way for you to give structure to your dictionary, or a shape to your dictionary, to specify if you want to send a dictionary into this function, this is what it should look like. This is an example of the attributes. Again, the errors that you're going to get, and we're going to move forward. Now what you're seeing here is character that incorporates the previous typed dictionary. So you're building a typed dictionary which incorporates the previous typed dictionary. And now I'm changing the update attribute function. This is what it would look like, a proper version of it using proper typed annotations. So now if I look at this spec, I can see I need to send in a character object, or in this case, and if I hover over that, I would be able to see the spec of what I need to send in. Attribute name, it would be one of those literal values that I need to send in, and I'm going to be returning a basic type int, is what the function will return. So this is how you create a character. Pretty simple. And now character is part of typed dictionary. So if I do anything wrong here, I will get a warning. And this is an example of two warnings I might get. One is where might is lowercase. The other one is where insight has a non-integer value. And we have the two errors there. Might is an undefined item in type attributes, or literal 39 is not assignable to int. We still do not have runtime protection. So what you can see over here is I can still execute that code and I can still insert it into my backend, which is a problem. And that's a problem we're going to fix. So we're going to move from typed dictionaries and literals to Pydantic. Let's quickly do that. So here we're going to build a Pydantic, and the first thing we'll do is use annotated. So annotated is an amazing type annotation. It's a basic type, or any type, but you're adding metadata to the type. And the metadata is not just text. In this case, what I'm doing is I'm adding an object to it. I'm basically saying that field, and I'm passing two values into field, GE equals 1 and LE equals 100. That's a Pydantic methodology there. Greater than or equal to 1, less than or equal to 100. So what the annotation is saying is that that integer value needs to be within that range. Very important to note that the actual integer, when executed by Python, will not be protected by that. It's only within a Pydantic model that you will get that protection. Then what I'm doing secondly in line 6 is I'm creating a new type that will incorporate our annotated type union none or optional none, which means it's an optional version of the attribute value. So if we move on, we're going to create now a base model. I'm going to cover all the different settings that we have there in model configuration. And then we're going to look at the annotated type. So let me firstly look at annotated down there, line 15. So we're defining might, and we're saying that we're defining an annotated type of optional attribute value. That's the type we defined up there, the optional version of it. And we're also attaching additional field properties. We are attaching an alias and a description. So we're now creating a lot of information in might. We're attaching constraints, the 1 to 100. We're attaching an alias, which you'll see now what that's used for, and also a description, which you'll see in the API, that Fast API absorbs and helps you to create a documentation. Let's firstly look at the top over there. So validate assignment means that any data that gets assigned to this model will be validated according to whatever the rules are that we've specified here. And Pydantic's validations all pass over to Rust. So it's incredibly fast, especially if you're doing incredibly high volumes of data. This is not Python code, it's Rust code that does the validation. Populate by name means that you can use the actual name of the attribute. In this case would be might with a lowercase or vitality with a lowercase, or you can use the alias to populate. You'll see that in action right now. And then also extra forbid means we're not allowing any additional values. Down there would be what the character base model would look like. So the name would be a basic string, and then attributes would be the attribute base model that we're incorporating. This is the changes that we require in the update attribute. The biggest thing we're doing here is that line 47, which is update, and then we're going new attributes, and we're dumping that model, and we're excluding anything that's unset or anything that's none. Why are we doing this? Why am I doing that specific thing there? So when somebody sends data in, remember in our previous function, we only allowed one single attribute update at a time. Now somebody can send an entire set of attributes in, and the ones that they send in will be updated, which makes this function way more flexible. So characters, the type annotation, new attributes would be what's sent in. We're returning nothing. That's where we're dumping it, and that's where we're doing the update right now. So this is how you'll create an object of type attributes, line 2. And then line 6 is where we're creating an object of type character. And we're passing in the attributes. We're also giving Silvara a name. So that's our character that we're creating. And then we're printing out what we're seeing here. So let's look what that update looks like. And look at line 11 over there. That's where we're doing the multiple attribute update in one shot. Which means this is, instead of 3 calls, we're now doing 1 call, which is great. But we also have protection around that. And I want to show you what that looks like. So if we're doing, in this case, we're updating might with 120. Remember that there's protection in the back end around that. So we have that constraint that says only 1 to 100, and now we're trying to update it to 120, and this is runtime protection that Pydantic gives you. So 120, nope, that's not allowed. It needs to be 1 to 100. And then the result of the update is it's going to be rejected. So we still have our valid data. Over here you have an incorrect spelling for might. You're getting the same type of error over there. Attribute might is not accepted, and that's because of the extra values being rejected. This is an example of Pydantic type coercion. So if I'm sending in 39 string, it coerces that to an integer. Have a look at the bottom over there. Once we print out the character after the creation, it's an integer on the inside. And this is an example of using the name agility. So now once we have this backend, we can create fast API in this case 4 lines of code. I want to make this a bit more flexible because I don't like the idea that we are connecting our character object to our fast API. You typically want loose coupling here. You want something between this. And now this is an area where Pydantic shines. In clean architectures, when you need to send data into your application layer from the delivery layer, which is in the front, let's do that. So to do that, we're going to just refactor the character model, just call it character model, add an ID over there. We're creating 2 classes here for data type object, one for the requests that need to come in, and that'll be any type of request. And I'm going to show you how Fast API as well as our command line use the same DTO to send data into the backend. And then we'll respond with a response DTO. We're adding a generate character ID here. So this is just where we generate our IDs, and that's the new update attribute function. And then finally, we're creating this new function here, create character use case. So the create character use case will receive the create character request data transfer object, and it'll respond with the response. These are the changes we're making to Fast API. So over here we're saying Fast API, the response model will be that response that we're going to receive. It's going to be, we're going to be sending or the person who's requesting this API needs to send in the character request DTO. And this is what's going to be used to generate the documentation that you're going to see. It'll analyze whatever is in that model and generate the docs out of that. And then this is how we create the return value. We're calling that create character use case function and returning that. Let's look at this in action. So just like that, we have our API working. We can look at that domain. Let's update that 120 to 100. And now everything's updated. So all of our code, as you can see, because we only updated one place, but we used that that annotated field for all of the different values. All of them have been updated now. And you'll see this update everywhere. You'll see it here. You'll also see it in our Open API spec. And as you can see here it's giving us two things, giving us that description that comes from the annotated field, and it's giving us the maximum value that we just updated to 100. So we're also going to build this command line interface. So this is 6 lines of code, I think maybe 7 if I exclude the imports at the top over there. And we're using Fire, and this is also going to give us the same protection. So if you're using our code, by the way, you can clone our code repository on the Voyager Requests GitHub channel, and if you want to execute it, this is what you need to do. You'll type in UV sync to create your UV virtual environment, and then you will install a local version of this package like that, and then you're executing character. The reason you can execute character is because these values, the config over here. Have a look at line 20 and line 23. So let's use this command line. Okay, spelling mistake over there, so it's going to reject. Once I try to update this, I'm getting inputs are not permitted. ALT is not permitted. Okay, let's fix that. And there we go. We have our character created in the back end. So let's move on. Behavioral and generic typing. This is an interesting type of type. So firstly, let's look at callable. I don't know if you're familiar with a strategy pattern. Strategy pattern is where you're sending functionality into another function to execute. This is a good example of that. We have an apply operation. It takes an integer as well as an operation, but the operation is going to be a function. How do we annotate that? This is exactly how. Line 6 over there, operation needs to be a callable, and then you'll see 2 values in a list over there. The first value is the parameter, and the second value is the return value for the callable, which will be a function. And then if you look at this, we have 2 functions over there, double as well as square. And then line 19 and 20 shows you the usage of those. We're passing in double and we're passing in square. Generic types. So generic types give you the ability of defining types as parameters. We used to have to import type value. You'll see at the end that's not necessary anymore. To define a generic type, now all you do is in your function definition you put square brackets, and you add a name for the type. So in line 2, I'm just showing you what this could look like. It's not really the way it's normally used. The way it's normally used, line 6. So it's line 7 really. It would be a capital T. The reason I showed you line 2 is sometimes people think the capital T is something special. It's just a name. And you're then stating what the type is. So what this tells us is whatever type is being sent in will also be returned in this identity2 function. But you can send in any type. The only rule here is whatever the type is that's coming in will be the type that's sent out as well. So this is an example of a pair where it does actually make sense to use descriptive names for your type variable names. And this is an example of where you can be more domain specific with your naming of a function. So you're saying basically send in a message and I will return a message, but different types of message classes are supported here. So now we're getting into protocol. Don't know if you've used protocol before, but it's a lot of times people want to do certain things like create generic functions using abstract base classes. Protocol gives you a lot of the same benefits, but without using inheritance to achieve it. So let's look at what protocol would be. So over here we're using protocol has name. And what we're defining is that any function that has the get name and returns a string will adhere to this protocol. So that's the simple idea behind it. It's sort of a rule. The rule here would be you need to have get name. You can have other stuff, but you at least need get name, and it needs to return a string, and the ellipsis at the end there will always be when you define the protocol. You're basically saying we're not defining the function here. We're just saying it needs a function like this or a method like this. So greet is an example of a function that's now got an annotation that says I will only accept functions that has this protocol. In other words, I'm only going to accept a function that has a has name or that has a get name method. So that I don't break stuff. And again, you want the IDE to warn you before the time that I'm sending something in here that does not adhere to the protocol, because guess what? Something's going to call that protocol. So as you see over here in line 7, entity is what's being passed in, and we're calling the getName method on entity, which is what the protocol is protecting us against, sending an entity in here that does not have that, which will result in a breaking change or breaking failure. So we have two classes over here, team with a getName method and user with a getName method. And both of those, as you can see, so this is also something to note. When you're implementing the class, you don't annotate it with the protocol. You only annotate the function that you want to protect. The actual class doesn't even know about the protocol. That's the difference between inheritance. If you're using inheritance here or mixins, then there's a connection, a tight connection between them. The classes we define here, all they need is they need the getName function to adhere to the protocol, which is great. It gives you a lot of flexibility. Okay, so now you can also take the next step and do protocols with variable types. And I'm just going to quickly show you what that would look like. So here we have a has name, but it can have a variable type. And in this example, the name can potentially be any type, because we have a robot there at the bottom that has a numeric name, line 20, and we'll get there. So we want to be able to support a getName function that does not necessarily return a string. And that's what we're doing over here. So that's the greet, again the user class, the robot class, and that's the usage of it. And that was that. Let's run through what has changed. Modern generic types, so you no longer need to import list and dictionary from typing. You will basically just use list, dictionary, or the different types that I showed you right at the beginning. The union syntax, no longer import union or optional. Union would simply be the pipe, and optional would be when you use union and none. So over here, this would be the type parameter syntax. You used to have to import type variable. Now you're just saying first, and you have your square brackets there with a value in there. That'll be the value for your type. And in that way, you're defining that this function is going to use a type variable. So over here, we have alias statements. You used to have to import type alias. It's not necessary anymore. Now you'll just say type. So what is a type alias? Type alias is we're defining a variable that contains a type that you can reuse in different places. You're not defining a type. You're basically defining a type annotation that you can reuse, if that makes sense. So forward references. The lucky thing here is there's nothing you need to do. So the only thing you need to do is stop using the old way. So the way old way pre-Python 3.7, and you'll see this in AI still, is that you'll see these quotation marks, which means it's a forward reference. You're using a type that's not yet defined, and this was just a way to tell your IDE this stop. First you go look for it, forward reference. Then in Python 3.7 to 10, you would have only had to done import from future import annotations, but that's not necessary from 3.14 anymore. It's just you don't have to worry about future. It's lazily loaded now and it's all sorted. Way better, way better. So that brings us to the end of this video. If you liked this, please like the video and give me some guidance on what you guys would like me to dig in on. If you want to follow a quest, we're busy with a quest to demonstrate how clean architecture is used to build a robust backend role-playing game system. We're focusing on a small version of that at this stage. If you want to actually run the code that I've got here, I'm going to dive into that right now. So just take a second or so, look at that. Or otherwise, I'm going to say thank you for joining and see you in the next video. So if you start with a clean repo, then what you do is you go to our GitHub repository, Voyager Quest. Go into repos, look for mastering Python, copy it, git clone it. Once you've cloned it, you'll see that basically there's a README file that you can read over there, but there's nothing more to that. Then just switch the branch to this video. Okay, and now you have, so what I did, there's some example files over there, notebooks that I created, presentation files. That's the API, fast API. Right over here, command line interface, and then domain. So over here you have README that you can look at. Let me just preview it real quick. So that's what it looks like when you preview it. So the PyProject TOML file, I modified a little bit to look at specifically line 20 and 23. That's what you're going to need if you want to run the command line interface. I'll show you now how to do that. So to run the code, UV run fast API dev. That'll start up fast API. That's all you're going to need. You basically will need UV installed. Apart from that, that's basically what you're going to do. Once you have fast API up and running, you can go to this location over here. Just look at the fast API code. You'll see on the previous screen there, it's going to show you where to go. Normally it would be 127.0.0.1 on port 8000/docs, like you've got over here. Okay, so this is the Fast API. Let's execute it. You see over here that I've got an ID auto-generated, which means it worked. Let's send in some wrong data. You see input should be less than or equal to 100. That's Pydantic protecting us. OpenAPI specs automatically written for you. You can copy that out, download it if you want. And then let's look at Redoc. So Redoc gives you a different UI. This is really nice documentation. This can also be hosted as a static site. That's one of the great advantages of Redoc. It's very easy to do. It's also easier to read than some for larger scale APIs. So as you can see, if I run character, that's the command line interface, it's not going to work. So what you have to do, you firstly need to sync. So UV-sync to create your virtual environment. Then you need to pip install -e dot. What that does, it creates a local version of your package installed inside your virtual environment. So it's still not going to work. Let me show you this. So you see character still not working. You will have to source into the virtual environment. If you have a Mac, that'll be source.venv/bin/activate. If this is Windows, you'll run the activate script as normal. Now it will work. So inside our CLI, you can copy that code over there. Just going to copy all of it. And then I'll go to the front, just delete that hash. That's it. We have a working API. Let's edit it a little bit to break it. Good. I'm going to edit, show you another error. Let's edit 2 fields. So you can see 2 errors. There we go. Quick demo of CLI, API, and then you've got all the code here. Have a great day. Thanks for joining.